अस्सलाम वालेकुम एवरीवन, क्या हाल चाल हैं आप लोगों के? ओके, sir, can you do 27, 30, 32? I'm typing now because I'm not free during the time of your stream. Okay, so we'll do as many questions as possible. No worries. I did half of the questions from the PDF and was able to do about 80% of it, so I'm more confident. Thank you for your advice. What advice did I give yesterday? I mean, you're welcome. I appreciate it. I'm glad to have helped. But what advice did I give? AS Maths P1, next year P3. I got P1 and S1 in AS. Threshold to nahi badha doge. Is there anyone who finds physics easier than maths other than me? अच्छा, ये तो सब आपकी आपस में बातें हैं. Any question for me? Sir, can AdMath student watch this? No. Today's stream, the AdMath student should not watch this. It's totally pointless. Why? Because I will be doing a topic which is actually not even part of the AdMath syllabus. Sir, your title is the yesterday ones. Nope, it's not. It's actually part 2. Acha, you're talking about that? Oh, huh. I just noticed. Okay, it says O-level math. So परेशान हो गए होंगे. Just a minute. Thank you. जिसने भी point out किया ये. There you go. Fixed. Yeah. Thank you. अच्छा, या मैं समझ गया आप क्या कह रहे हैं. ठीक है. Sir, will there be IGCSE stream today? Yep, there will be. I will be doing, so right after this stream, I'm streaming IGCSE, in which I will be solving graphs of inequalities and coordinate geometry. So tomorrow will we do APGP? Let's see what we're doing tomorrow. Tomorrow, most likely, I think either equation of circles or APGP, one of the two. Sir, please tell how much significant... Oh, Allah. बस भी करो यार, significant figures. कोई examiner report खोल के पढ़ लो, पता चल जाएगा how many significant figures you have to follow. Sir, please reduce the timer for comments. No, I think the comment timer is fine because you guys then start spamming. Sir, how many past papers are required for A? Only if I had $1 for every time somebody asked me that. No way he said 30. Did I say 30? 30. Okay. Anyway, let's start. Today, like I said, inshallah, we will be focusing on volume-related questions. We will be doing area under the curve, and we will also do indefinite integral. So I will try and wrap things up in today's stream. कि पूरा integration इस stream में ख़त्म हो जाए. इसको 5 बजे तक, 4:30, 5 बजे तक हम stream करते हैं. ठीक है. If needed, there will be a part 2 also, inshallah. Okay. So let's begin. So I'm going to start with something fairly easy. Acha, before I start, as always, you guys know the deal. Please subscribe to the channel if you haven't done that yet, and also like the stream if you haven't done that either. Okay, so I'm just going to put my phone on do not disturb. I suggest you guys to do the same, and let's get to work. This PDF is available. You can download it from the link in description. I don't know how many times I've already mentioned that. Walaikum assalam. Just a minute. Okay. So, sir, you promised a P1 AdMaths trig vid, but never. But don't worry about AdMaths. Okay, don't worry about AdMaths. There's plenty of time. Okay, AdMaths कब है? 16th को है ना अभी. What do you think I should prioritize? People who have their exams on the 2nd or people who have their exams on the 16th? So obviously, I think you know the answer to it anyway. So let's start. Let's start with some easier questions, and then gradually we'll increase the difficulty level and do some difficult questions as well, inshallah. So what we're doing is, This is a question fairly recent from February, March 2020, paper 12. Let's see what it says. The diagram shows part of the curve with equation y is equals to x squared plus 1. The shaded region enclosed by the curve, the y-axis, and the line y equals to 5 is rotated 360 degrees about the y-axis. Find the volume obtained. Okay. Now, I will encourage you guys to download the notes. The notes are available free of cost on the website mathletebysart.com, and you will definitely benefit from the notes. So here, for example, when you're rotating about the y-axis, it's done in 4 steps. Okay, so what you do is you make x the subject. Then you square the answer of step 1. Okay, so that is if you're rotating about y-axis. You make x the subject, then you square the answer, and then you integrate with respect to y within the limits c and d. And c and d are basically the limits on the y-axis. And then finally, you multiply the answer by pi. Okay, so here, we can start by making x the subject. So when we make x the subject, what do we get? We have y is equals to x squared plus 1, correct? Now, if I make x the subject, y minus 1 is equals to x squared. Now, we've done 2 steps at once, okay? So, because the question was structured in such a way, we have not only made x the subject, but at the same time, it's squared as well. So, we don't have to square it again, okay? Please don't make the mistake of squaring it again. It's already squared. ये नहीं कि बस अब आपने रट लिया कि स्क्वायर करना है तो बस स्क्वायर ही करना है कुछ भी हो जाए नो you just have to make x the subject and then you have to square it. So we've done that. That means now what we have to do is we have to integrate y minus 1 within the limits 1 and 5, and in the end don't forget to multiply the answer by pi. So I don't know what the big deal is, why people make a big deal about volume. It's not that difficult, honestly. It's just 4 steps that you have to follow. Yes, sometimes it's difficult to identify how to find out the volume of the shaded region, but we're going to learn a simple trick for it, and you guys can apply that trick to pretty much every question there is. So y squared upon 2 minus y within the limits 5 and 1, and in the end don't forget to multiply your answer by pi. So let's plug in 5. 5 squared is 25, so 25 upon 2 minus 5. 25 upon 2 minus 5, that's with the upper limit plugged in, and then let's plug in the lower limit, which is 1, so 1 upon 2 minus 1. So 25 upon 2 minus 5, make sure to use a calculator for this. Please don't work it out mentally. 25 upon 2 minus 5, so that's equal to 7.5, or you can write it as a fraction also if you want. Minus half minus 1, this is equal to minus half. So 7.5 minus half, that's equal to what? That's equal to 8, and don't forget that in the end you're supposed to multiply the answer by pi. So your final answer is simply equal to 8 pi. Now, I do agree that this was a very easy question. We can't, on the basis of this, say that this is how easy it is. But more or less, you will find the difficulty level, the step-by-step procedure, more or less, you will notice is the same. Okay, now you can leave your answer in terms of 8 pi. If you want, you can write it. You can multiply it by pi, the actual value of pi, and give your answer to 3 significant figures. Okay, so let's do some more questions. So we'll do both today. We'll do volume as well as area. Okay, so let's do this question. I like this. This question says the diagram shows part of the curve y is equals to 8 over x plus 2 and the line 2y plus x equals to 2. Sir, can you do? Yeah, I will do those questions, but I don't want to immediately jump to a difficult question. Sir, you said in the differentiation stream that circular measure. Yeah, so circular measure, coordinate geometry, APGP, equation of circles, trigonometry. I just hope we have enough time before the exam. These are all topics that I want to stream. I might have to sacrifice one. Let's see. I'll probably do a vote on my Instagram. You guys can tell me which topic I should stream next. But anyway, find by calculation the coordinates of A, B, and C. So this is a 6-mark question, 6 easy marks. You could give this question to an O-level students and even they will be able to do it. So just make sure you're also able to do it and you don't end up making a silly error or something like that. And also, please be advised that when you're solving, it's also important to make sense of your answer. So here the question says the diagram shows the curve and the line intersecting at points A, B, and C. It doesn't say anything whether A is a point on the y-axis or not. It seems like it is, but it doesn't say anything. It says the point C lies on the curve and the tangent to the curve is parallel to AB. Okay, let's see what we can do. So first of all, as far as A and B are concerned, A and B are basically the points of intersection. Okay, so let's find out the point of intersection. So 2y plus x is equals to 8. That's your first equation. Y is equals to 8 upon x plus 2 is the other equation. So what should we do? Should we make x the subject or y the subject? I think I'll make x the subject. That way I won't have to deal with fractions. So x would be equal to 8 minus 2y. Okay, so x is equals to 8 minus 2y. We're going to plug that in here. So y is equals to 8 upon 8 minus 2y plus 2. Simplify before you cross multiply to make your life easy. So y is equals to 8 upon 8 plus 2, that's 10. 10 minus 2y. Achha, always be aware of the amount of space that you're given. It's not a lot, so just make sure that you use it efficiently. Now, when you cross multiply, you have 10y minus 2y square is equals to 8. Now, let's write this nicely. Let's move all the terms to the right-hand side. So, 2y square minus 10y plus 8 is equals to 0. Let's divide the entire equation by 2. So y square minus 5y plus 4 equals to 0. Now, we had this discussion yesterday where I told you guys that you are supposed to show middle term breaking. And you should also use your calculator to check your answer. So we take y common, and then we take minus 1 common. So we have y minus 4 once again. Okay, now we can write down the final value, which is y is equals to 1 or y is equals to 4. Okay, y is equals to 1 and y is equals to 4. This is question number 5 of the worksheet. Okay, so now that we have y is equals to 1 and y is equals to 4, what we're going to do now is we are now going to plug in these values in the equation where we made, x the subject. Okay, so I should have utilized this space a lot more efficiently because turns out we don't have a lot of space. Which is why it's important that if you guys are solving past papers right now, you guys do it on the print it out and then do it, so you learn how to manage it within the space that's given. Okay, so let's find out x. So when y is equals to 1, so 2 times 1 is 2. 8 minus 2, that's equal to 6. Okay, then if you plug in 4, so 2 times 4 is 8. 8 minus 8, that's equal to 0. Okay, now make sense of your answer. Which point which point do you think will have coordinates 6, 1, and which point do you think will have coordinates 0, 4? So using your common sense, which I know is a big ask, but 0, 4 is definitely the point A, and 6, 1 is definitely the point B. Okay? Acha, what about C? Now you can see that you guys are debating over C. C is not the midpoint. Okay, now those of you who think it seems like it's the midpoint, it shows it's in the middle. No. If you cannot conclude for sure, if there is no evidence given, then you're not going to conclude on the basis of looks. Okay, oh, it seems like it's in the middle, so might as well take that. No. Okay, so there has to be concrete evidence. You should be able to back it up. Now, we're not going to use the concept. There's nothing to do with the midpoint here, basically. The question says the tangent to the curve at C is parallel to AB. So here's what we're going to do. Parallel means the same gradient. Now, please don't be afraid of making a rough sketch. So here we have the tangent at C, and according to the question, these two lines are parallel. What do we know when two lines are parallel? What do we know when two lines are parallel? They have the same gradient. Okay, so what we're going to do is we're going to find out the gradient of AB. Okay, so let's find out the gradient of AB. So what's that equal to? That would be equal to 1 minus 4 over 6 minus 0. 1 minus 4 is minus 3. 6 minus 0 is 6. So that means the gradient of AB is minus 1 upon 2. Okay. Now this will be the gradient of this line as well. And once again, make sense of your answer. This is a downward sloping line, so it better have negative gradient. And it does. Now what we're going to do is we're going to differentiate this. Okay. And we're going to equate it to minus 1 upon 2. Okay, so we're going to differentiate it and we're going to equate it to minus 1 upon 2. Now, I got to be honest, I'm actually surprised about the amount of space that you're given. Okay, it's not a lot. So just utilize it efficiently. Now, how would you differentiate? Here's how you would differentiate. 8 into x plus 2 to the power 1, that's y. So that means dy by dx is equals to minus 8 into x plus 2 to the power minus 2. Now, what is this equal to? Minus 8 over x plus 2, the whole thing squared, is equals to minus 1 upon 2. So minus minus cancel. When you cross multiply, you have x plus 2, the whole thing square, is equals to 16. That means when you take the square root, now we'll only take the positive square root because we can see that the point should have a positive x coordinate. So x plus 2 is equals to 4. That means x is equals to 2. Now what about y? For y, simply plug in the equation value of x into the equation of the curve right here. So if x is 2, 2 plus 2 is 4, and 8 upon 4, what's that equal to? That's equal to 2. Let's see if that's correct. Yeah, so y is also equal to 2. So that means we have the coordinates of C, 2, 2. Okay, now I'll walk you guys through the solution once again. So basically, here's the deal. A and B is quite simple. A and B is basically the point of intersection of the line and the curve. C is basically a point where if you draw a tangent, it's going to be parallel to line AB. So what we do is, once we have the coordinates of A and B, we find the gradient AB. Okay, we differentiate the equation of the curve and we set it equal to the gradient of AB. Okay, that gives us what? That gives us the x coordinate at which the gradient is equal to the gradient of AB, meaning the gradient is equal to the gradient of tangent at C. Okay, so here's what I've done. Once we have the coordinates of A and B, we find out the gradient of A and B. We know that the tangent to the curve at C also has gradient minus half. So we differentiate the equation of the curve. We set it equal to the gradient minus half. We have the x coordinate. What does that mean? That means that's basically the x coordinate where the gradient of the curve is equal to minus half. And we know that is basically the point C. And what's that? That's equal to 2. And what's the corresponding y coordinate? The corresponding y coordinate is also coincidentally equal to 2. There you go. Okay, now let's do part 2, part B. Part B says find the volume generated when the shaded region bounded by the curve and the line is rotated 360 degrees about the x-axis. Okay, 360 degrees about the x-axis. Okay, now एक काम करते हैं. Let's get rid of this. Let's get rid of this also. Let's take a screenshot. Undo, bring all the stuff back. Here. Okay. Now remember, when it comes to area, when it comes to volume, planning is key. Now, how would you find out the volume of the shaded region? Question for you guys. How would you find out the volume of the shaded region? So please mention which question is hard from examiner point of view. Okay, I'll do that. Y square and pi. Okay, that's correct. That is correct. It's a washer. What do you mean it's a washer? Volume under the line minus the volume. That's correct. So here's a simple trick. With volume, people usually get confused, but here's how not to get confused. What would you do if you were to find out the area? You would find the area under the line, and then you would subtract the area under the curve. Simple as that. So what you're going to do here is you're going to find out the volume generated by the line and the volume generated by the curve, and then subtract the two. Simple as that. Okay, it's lengthy, definitely. We're given a lot of space, but it's not that difficult. Okay. So, volume of line minus volume of curve. ठीक है, ये plan वाला part बहुत ज़रूरी है. ठीक है, remember the famous saying, if you fail to plan, you plan to fail. बेटा थोड़ी stream का, okay, who's gonna tell him? Tell him कि stream को थोड़ा आगे बढ़ा दे. I don't think he knows that there is an option to do that. Khair. So let's find out the volume that's generated by the line. Now remember, because it's about around the x-axis, so we're going to make y the subject. Okay, so let's make y the subject. 2y is equals to, so we're focusing on the line. Okay, so it's a good idea to write this so that you have a sense of direction. So the line has equation 2y plus x equals to 8. Okay, let's make y the subject. So y is equals to 8 minus x upon 2. Okay, so here we have the line. Now what we're going to do is we're going to write this separately so that it's easy for us to integrate. So 8 upon 2 minus x upon 2. 8 upon 2 is 4, so 4 minus half x. Yeah, let's write it as 4 minus half x since it's easy to integrate that way. Okay, so let's find out the area, that is the volume that is generated by the line. Okay, so that means 4 minus half x the whole thing squared, and we're going to integrate this. What would be the limits, by the way? The limits would be the x coordinate of b and the x coordinate of a. Achha, what are the x coordinates? The x coordinate of a is 0. The x coordinate of b, we figured to be 6. Okay, seems like we're on the right track. So 0 and 6. Now, so we'll integrate this like we integrate a composite function. That is, we will add 1 to the power. So that's equal to 3. We'll divide it by the new power. That's 3. And we will then also divide by the differential of the expression inside the bracket. Okay, now you can expand it and then integrate it. It's up to you, but you can do it directly also. It's entirely up to you. Okay, and don't forget the limits, 6 and 0. And also don't forget that you have to multiply by pi. Okay, so 3 into minus 1 upon 2. And then when we take the reciprocal, so we get minus 2 upon 3. So minus 2 upon 3 into 4 minus half x. Please be very systematic with your working. It's going to give you confidence also, and it's better for the examiner as well. And don't forget the limits, 6 and 0. Now what I'm going to do is I'm going to take this entire constant outside. Okay, I'm going to take this constant outside. Purpose is just to make my life easy. So minus 2 upon 3 pi. So I can just focus on plugging the limits. And then don't forget that you have 4 minus half x, the whole thing cubed, within the limits 6 and 0. Okay, now I'm going to plug in the limits. So 4 minus 1 upon 2 in place of x, I'm going to plug in 6. Okay, and don't forget to cube the whole thing. So we have 1. So minus 2 upon 3 pi as it is. Okay, the upper limit plugged in, that's 1. Now let's plug in the lower limit, which is 0. And we have 64. Okay. So 1 minus 64 into minus 2 pi divided by 3. So we're looking at 42 pi. Okay, so let's put this 42 pi on the side. Okay, so we have 42 pi. Let's put this on the side. This 42 pi is basically the volume generated by the line. Okay. Now, let's focus on the volume that is generated by the curve. Now, what's the equation of the curve? The equation of the curve is y is equals to 8 over x plus 2. Now, let's square it. If y is already the subject, so we don't have to worry about it. So since this is what we're supposed to do within the limit 0 and 6, the same two limits, so that means this is what it looks like. 8 upon x plus 2, the whole thing squared, which will be integrated within the limits 6 and 0 multiplied by pi. Okay, so what does this become? This becomes 64 over x plus 2, the whole thing squared. Do not make the mistake of expanding x plus 2, the whole thing square. Otherwise, good luck trying to integrate it. Okay, so let's make it integration ready. Let's write it in a way so that it's easily integratable for us. That is, we will let 64 be as it is, and we will shift x plus 2 in the numerator. So that way the power becomes negative. And don't forget the limits, 0 and 6. Okay, so we add 1 to the power, 64 into x plus 2. We add 1 to the power, that is minus 1, divide by the new power, which is also minus 1, and also divide by the expression of differential of the expression inside the bracket, which is going to be 1, so it's not going to make any difference at all. And don't forget that you're supposed to multiply by pi. Okay, now 64 over minus 1 is minus 64. We take the pi, we take minus 64 outside, so that means what we're dealing with is this. Minus 64 pi. Okay, and what's going on inside the bracket? This is what's going on inside the bracket. You have 1 upon, so I'm going to make it positive so that we can easily plug in the limits, x plus 2, and the limits are 6 and 0. Okay, so now let's plug in the limits, minus 64 pi. Okay, so don't forget that. The upper limit is 6, so that's going to be 1 upon 8 minus, with the lower limit plugged in, 0, 0 plus 2, that's equal to 2. Okay, so let's work this out. Use your calculator, please. Don't be over smart that you can do it mentally. I'm sure you can, but now is not the time to test your mental math. So minus 64 pi into minus 3 upon 8. So, sorry, not minus 6 pi, minus 64 pi. So into minus 64, we're looking at 24 pi. And that's it. We now have to put the two together. 42 pi minus 24 pi, line minus the curve. And what's that equal to? That's equal to 18 pi. Can anyone confirm if that's the answer? Yes, well, I'll just check myself. And there you go. Mazaya? Okay, sir, can we just do both integrations together to solve more questions? I don't know what you mean by that. Okay, sir, do we have to open the bracket? When do we have to open the brackets? See, here's the simple test. If you can integrate without opening the brackets, just simply don't open the brackets. Simple as that. Okay? All right. Extremely off topic, but what chair do I use? Where do you live? Are you based in Pakistan? Because if you are, then I'll tell you exactly where I got it from. Okay, now somebody asked me to do question number 40. So let's do 40. Okay, but we'll do this question also. I like this question. Yeah, I like this. 40, 40, 40, 40. 39, 40. All right, let's do this. Let's do 40. Let's see what this is. I got scammed. My question paper book has half the space. So they probably tried to save space. But anyway, as long as you have all the questions. Karachi. So I got it from this place called Interwood. ठीक है, तो Interwood से मैंने लिया. I don't remember the exact model, but that's where I got it from. They have good variety for chairs. I heard if differentiation of bracket doesn't only give constants, then you have to open. Yeah. So if inside the bracket you have a linear expression, then you can use the composite function rule. But if you don't have, that is basically for integration. Okay. So yeah. See, if you can do it without opening the bracket, just do it without opening the bracket. It's as simple as that. Now this question says the diagram shows part of the curve with equation so and so, and part of the lines x equals to 1, y is equals to 1. Find the exact volume when the shaded region is generated 360 degrees above the axis. I think it's that question where, no, it's not that question. Anyway, but let's solve this. Find the exact volume generated when the shaded region is rotated 360 degrees about the x-axis. Okay, now how would you solve this question? The way that you would solve this question is that you will, if let's say you were supposed to find out the area, so you would find the area under the curve within the limits 3/2 and 1, correct? And then you would minus the area under the line. Okay, now the same way you will do volume. You will find out the volume that is generated by the curve when this part of the curve between 1 and 3/2 is rotated 360 degrees around the x-axis. And then you will subtract the area, the volume that is generated when this line is rotated. Okay, so simply volume of curve. Okay, now volume of curve means volume generated by the curve minus the volume of line. अच्छा, now I know some of you might say कि sir ये जो line है इसको हम cylinder भी treat कर सकते हैं, and you're absolutely right. Okay, you can actually treat this as a cylinder also, but I don't use that approach anymore. Why? Because it is a shortcut, but it has very limited applications. Achha, by the way, the equation of this line will be y is equals to 1. Okay, it's a horizontal line, and the y-intercept would be 1 if you extend it, so the equation would be y equals to 1. Achha, why not the other line? Because it's about the x-axis. Okay, so it's about the x-axis. So you will first find out all this volume, and then from that you will have to subtract all this volume. Okay, so that's why you're not going to use the other line. Okay, so now let's focus on the curve. Let's first pay attention to the curve. What's the equation of the curve? The equation of the curve is y is equals to 4 over 2x minus 1, the whole thing squared. Okay, so first thing we're going to do is we're going to square it. Okay, so it's not squared, so we'll square it ourselves, no problem. When you square, be careful. There is already a square in the denominator, so that would be 16 over 2x minus 1, the whole thing, power 4. Okay, so patience is key here. Don't rush into it. Okay, so there's nothing you're going to achieve if you're the first one to solve this question. If you have time, don't rush into it, and check as you go along. Okay, don't think that you will have time towards the end to check your answer. You won't. Chances are you'll probably won't. Okay, so let's integrate y square within the limits So let's talk about the limits in a minute. Power 4. The limits will be 1 and 3 upon 2. So 1 is the lower limit, 3 upon 2 is the upper limit. So let's make it integration ready. So 16 into 2x minus 1, the whole thing power minus 4. Okay. अच्छा मेरा आपको एक और मशवरा ये है कि इसके साथ साथ you bring the constant outside. Okay, so where pi is waiting for us outside, you bring the 16 also. And now you have the limits. Okay, so we haven't integrated it yet. Yeah, so just a minute. अभी हमने integrate नहीं किया. So I'll leave the integral sign intact. Okay, now let's integrate it now. So 16 pi 2x minus 1, you add 1 to the power, so minus 4 plus 1, that's minus 3. Divide by the new power, that's minus 3, multiplied by the differential of the expression inside the bracket. So there you go. Don't forget the limits, 1 and 3 upon 2. 3 upon 2 and 1. Okay, so 16 divided by minus 6. So what's that? Notice that even for the basic for some very simple calculations, I'm still using a calculator. Why? Because the stakes are high, so I don't want to risk it. So minus 8 upon 3 pi outside. Inside the bracket, you have 1 upon 2x minus 1. I've made it positive. And the limits are 3 upon 2 and 1. ठीक है, जितने high stakes होते हैं, उतना careful आपको रहना पड़ता है. Okay, so now let's plug in the limits. So we have minus 8 upon 3 pi. ठीक हो गया? Okay. अब देखो, I'll show you how exactly I'm doing this in my calculator so that you guys can also practice the same way. Just a minute. Okay. So we have 1 upon, I forgot to put the cube. Yeah, I forgot to put the cube. Yeah, so 1 upon 2, bracket open. Now what's the limit? The limit is 3 upon 2. So 3 upon 2, close the bracket, minus 1. And then don't forget to cube the whole thing. There you go. 2x minus 1, the whole thing cubed. We plugged in the limit, 3 upon 2. What do we get? We get 1 upon 8. Okay, so 1 upon 8. And now, where you've plugged in the upper limit, just plug in the lower limit. Okay, so what's the lower limit? The lower limit is 1. And what's that equal to? That's equal to 1. Simple as that. Okay, so let's see what we're dealing with. We are dealing with 1 upon 8 minus 1, that's equal to minus 7 upon 8. So that means we end up with minus 8 upon 3 pi into minus 7 upon 8. So cancel, minus minus becomes plus, and what do we have in the end? In the end we have 7 upon 3 pi. Acha, what's that? Why did we multiply 2 in the denominator? So don't you divide by the differential of the expression inside the bracket, rules of integration. Okay, so what have we found? We have found the volume that's generated by the curve. Now let's focus on the volume that is generated by the line. ठीक है, अब देखो लाइन के लिए ना दो तरीके हैं, मैं दोनों तरीके आप लोगों को करके दिखा देता हूँ. ठीक है, दूसरा तरीका I don't encourage it because you don't have it's basically learning a really cool trick which you cannot apply. Okay, so that's why I don't encourage it. ठीक है, but I will teach it to you anyway. So for the line, remember the line has equation y is equals to 1, because even if you don't use the trick, you will still get the same answer. Okay, and I mean answer to chalo same hi aayega, but you will still have to do the same amount of working, more or less. So we integrate y square. Okay, and y square basically means 1 square, so no need to square. I mean, nothing's going to change. 1 square is still 1. Now, what are the limits that we're going to use? And just so you guys know, we're now basically finding the volume that is generated by this line when you rotate it a full 360 degrees. Now, I know very well that it makes a cylinder, okay, but I'm not using that. It just makes things complicated. So the limits are 1 and 3 upon 2. So we have 3 upon 2, the upper limit, lower limit is 1. So 1 squared is basically x. So that means we're integrating x within the limits 3 upon 2 and 1, and then we're multiplying it by pi. So what happens when you, wait a minute. Integral of 1 is actually equal to x. So now we no longer need to write down the integral sign since I've already integrated it. I'll just do it again. So we're doing integral of y squared within the limits 1 and 3 upon 2 multiplied by pi. So that means we're integrating 1 within the limits 1 and 3 upon 2 multiplied by pi. So the integral of 1 is x. So that means the limits that we're plugging in is 3 upon 2 and 1 multiplied by pi. Okay, so what do we have? 3 upon 2 minus 1. So 3 upon 2 minus 1. And don't forget to multiply it by pi. 3 upon 2 minus 1 is 1 upon 2. 1 upon 2 multiplied by pi. That's it. Now what we have to do is we have to subtract. So we have 7 upon 3 pi. That was the volume generated by the curve. Minus 1 upon 2 pi, the volume generated by the line. So let's work it out. 7 upon 3 minus 1 upon 2. And what's that equal to? That's equal to 11 upon 6. Okay, now I'll take your questions. I noticed that you guys have asked a lot of questions. So I'll answer them one by one. Acha, what's that? Sir, can we do this step directly without? No, you have to show the working. Yes, no, not for me. Why didn't you check your answer? Yeah, that's a good thing that you pointed out. So maybe if you guys can check and tell me if this is the correct answer. Sir, but in some questions, denominator is not multiplied. Can solve another example after this. Beta, I don't know what you're talking about. Denominator is always multiplied. Okay. Why can't buy negative in any? Achha, that's probably not for me. Achha, that's great. Okay. Achha, you will never get. So, देखो, these are volume हो गया, area हो गया. These are basically stuff that have to be positive. Okay, sir, please answer. Could you do May, June 20? Tell me what question number this is from this PDF. Achha, also the other trick. Alternatively, एक चीज़ that I want you guys to understand is that if you rotate a line, okay, now remember, this thing does not have a lot of application, so just take it with a pinch of salt. Because you will rarely find questions where you can use this concept. So if you rotate a line 360 degrees, so ये line घूम के यहाँ पे आ गई, okay? So that means the shape that is formed is basically a cylinder. Okay, so think of it like a toilet roll. Okay, so toilet roll is what? I know it's a silly example, but it works. So it's basically a line rotated 360 degrees. What's the shape? The shape is basically a cylinder. So that means you now have a cylinder. ठीक है, तो जब आप एक लाइन को 360 डिग्रीज रोटेट करते हैं तो वो क्या बन जाता है? वो एक सिलेंडर बन जाता है. Okay, not the most accurate cylinder, but you guys get the point, right? That if you rotate a line 360 degrees, it makes a cylinder. There you go. Okay. Now, how can you find out the volume? Here's how you can find out the volume. The radius, as you can see, will be equal to 1. This is the radius. The height, as you can see, will be equal to the difference between the limits. 3 upon 2 minus 1, which is equal to 1 upon 2. So you can find out the volume. Volume is equals to pi r square h. So that means the volume, let's do it over here. So the volume would be equal to pi into the radius, which is 1, squared into the height, which is 1 upon 2. So what do you get? You ultimately get 1 upon 2 pi. Okay, same as what we got earlier. Okay, so this alternative method is that you realize that if you rotate a horizontal line 360 degrees about the x-axis, it becomes a cylinder. Also, if you rotate a vertical line 360 degrees about the y-axis, it makes a cylinder. Okay? Okay. Now, question number 3. Question number 3. Didn't I already solve question 3? No, I solved question number 2. 3 is area. 3 is area. Okay, let me do some more volume related questions, then I'll do question number 3 also, okay? So I want to do at least one more volume related question. I had this question in mind. Yeah, let's do this one. Question 36. Okay, let's see if 36 is volume. 36, 36, 37, 36. So let's do this. Okay, this is a good question. 9 marks, good question. Yeah, you can do this in the exam. Of course you can do this in the exam. Why would I teach you guys something that you can't do in the exam? What's the point? So find the equation of line AB. Okay. I don't think this has any application. I mean, I don't think this has anything to do with part B, but let's do it anyway. So we first want the gradient of line AB. Let's see what's that going to be equal to. That's going to be 2 minus minus 1 over 5 minus 2. So 2 minus minus 1, that's equal to 3. 3 upon 3, that's equal to 1. So we have y is equals to, actually no wait, we have the gradient. And we want a point, so let's use the point, 5 comma 2. So y minus 2 is equals to 1, x minus 5. If the question does not specify how you should give your answer, then you can leave it like this also. Okay, just so you guys know, if the question does not specify, then you can leave it like this also. It's perfectly all right to leave your answer like this. If the question doesn't specify, अमूमन क्या होता है, the question says give your answer in the form of ax plus by plus c equals to 0. But here, since the question doesn't say that, so you can leave it like this. So why not the midpoint? Why would you want to take the midpoint? I mean, अगर आपके पास बहुत time है, आपका midpoint use करने का दिल कर रहा है, तो go ahead. ठीक है, but you just want any one point on the line, so you could use the midpoint also. But honestly, why would you do that? Okay, now let's do part B. So if the curve is under the x-axis by integrating the equation, we get area above the curve. No. See, if you're integrating the curve with respect to x, then you will always get the area that's between the curve and the x-axis. The reason why people think that we get area under the curve is because that's what we're so used to saying. Area under the curve, area under the curve, area under the curve. No. But basically what happens is that the area that you get is basically between the curve, the x-axis, and the limits. Okay, why the x-axis? Because we are integrating with respect to x. If you integrate with respect to y, you will get the curve that's bounded by the y-axis. Yeah. So basically, this is what integral looks like, right? So if you look at everything that goes into integration within limits, you have the upper limit. Okay, so these are all your boundaries. Your upper limit is one boundary. Your lower limit is another boundary. Okay, dx means with respect to x, that's another boundary. The curve is another boundary. So whenever you integrate, doesn't matter whether the curve is above the x-axis or below the x-axis, the four boundaries are the curve, number 1, the lower limit, number 2, the upper limit, number 3, and the x-axis. So if, for example, the curve is below the x-axis, okay, and you use the same two limits. So once again, the boundaries would be the two limits, the curve, and the x-axis. Okay? Because here, there's no such thing as area under the curve, because that would be infinite. All right, so please clear this confusion. We always think that it's area under the curve because that's how we're so used. That's what we keep calling it, but it's not always under the curve. It's basically the area between the curve and the x-axis. Now part B. Find the volume of improper integral is when you don't have limits. Okay, when you don't have limits, that's improper integral. Improper or indefinite integral. Find the volume of revolution when the region between the curve and the line AB is rotated 360 degrees about the y-axis. So then to get the area, okay, देखो, no need to be so formal कि ओ area चाहिए तो उसको minus से multiply करें, ये करें, वो करें. थोड़ा सा दिमाग इस्तेमाल कर लें. Area is what? A scalar quantity, correct? You know that you are finding out area, okay? So if your answer turns out to be negative, that means that's because the curve is below the x-axis. So just ignore the minus sign, simple as that. Okay, once again, don't look for formulas, don't bound yourself with formulas and tricks and all that. Just use your common sense. If the curve is below the x-axis and your area turns out to be negative, just don't write it with the minus sign, simple as that. Why? Because you know that you're giving the area. That's it. Because if I give you the formula to find out the area under the curve, if it's below the x-axis, you're going to sit down and memorize it. There's no point, okay? Our brain has limited real estate. So use that real estate for something productive. Now, Find the volume of revolution when the region between the curve and the line AB is rotated 360 degrees about the y-axis. So the line and the curve rotated 360 degrees about the y-axis. Okay. So if you were to find out the area, you would find out the area of this line. Okay. Then you would find out the area between the curve and the y-axis, and you would subtract the two. Correct? Now what we're going to do is we're going to do the same, except we're going to do it for volume. Simple. So we're going to do volume of line. Now when I say volume of line, I don't mean that the line has volume. It's basically volume generated by the line minus the volume of curve. Okay, so I think I know why the question made us find out the equation of line AB, because we're going to use it in this part. So now we do have to write it nicely. So y is equals to x minus 5. इधर ही लिख लेते हैं. We'll save some space. So y minus 2 is equals to x minus 5. Let's make y the subject. Y is equals to x plus 7. There you go. Y is equals to x plus 7. Can we create a cone? No, I don't recommend. I mean, बेटा आपकी ज़िंदगी में कोई कम मसले हैं? कौन है ये? मीनो स्टिक मैन. आपकी ज़िंदगी में अगर बहुत कम मसले हैं, ठीक है, तो आप बिल्कुल इसे एक मसले का इजाफा कर लें. लेकिन आई एम श्योर आपकी ज़िंदगी में ऑलरेडी काफ़ी मसले होंगे, तो आप और मसले ना पैदा करें अपने लिए. So y is equals to x plus 7 is the answer. Why isn't it curve minus line? Okay, because the line, here's the line. Okay, yeah, you guys are right, x minus 3. Okay, sorry. अभी पूरा सवाल गलत हो जाता. X minus 5, x minus 3. ठीक है, thank you. All right, so basically, we will first find out the volume that is generated by the line, and then from that we will subtract the volume that is generated by the curve, so that we get the volume that's in between. Okay, think of it this way. If you were to find out the area of shaded region, what would you do? You would do the area of the line. You'd find out the area between the line and the y-axis, and then from that you would subtract the area between the curve and the y-axis. Okay, so now you're going to do the same, except you're going to do it for volume. Simple as that. Okay, so let's integrate x minus 3, the whole thing square. Okay, so I've squared it. Oh, no, wait a minute. Since it's about the y-axis, remember you're supposed to make x the subject. Okay, so I'm going to put this in bracket so that I remember that I have to make x the subject. So x is equals to y plus 3. So that means, let's look at the amount of space. Acha, this is, don't be afraid, this is not the actual amount of space that you were given. Iske baad ek page aur tha, which I did, my team probably forgot to add, but no problem, I'll just add it myself. There you go. Okay. Okay. So we're gonna do y plus 3, the whole thing square. Okay, we're gonna multiply it by pi. And what are the limits that we're using? Since it's the curve and the y-axis, okay, so we're gonna be using the y values. Okay, so we're gonna be using the y values. So what are the y values? The y values are 2 and minus 1. Okay, 2 and minus 1. All right, so let's integrate. Now here, you can expand it and then integrate it, but why go through the pain when you can just do it directly? So within the limits 2 and minus 1, don't forget to multiply it by pi. So do we need to make x the subject, whether it's area or volume? But I really hope you don't have your exam on the 2nd of May, because if you do, judging by the kind of questions you're asking, I want to wish you the best of luck. So y plus 3, the whole thing square, within the limits 2 and minus 1. So 1 upon 3 pi. Now let's plug in, the whole thing cubed. So let's plug in the limit. Let's plug in 2. 2 plus 3 is 5, so that's going to be 5 cubed. Okay, might as well just write it as 5 cubed. That's 125. Then let's plug in minus 1. So minus 1 plus 3, the whole thing cubed, that's equal to 8. Okay, so let's work this out. 125 minus 8 into 1 upon 3 pi. So we're looking at 39 pi. Okay, what are we looking at? We're looking at 39 pi. Now let's put this on the side. Okay, let's put this on the side. We'll come back to it in a minute. मैंने Zenomatics को बिल्कुल subscribe किया हुआ है. I think he's doing great work. Sir, why is it for whole 9 marks when there is not much to do? Okay, no, there is definitely much to do. Okay, so just take it easy, sit back, relax. There's plenty to do. Sir, please answer my question. बेटा आपको x को सब्जेक्ट सिर्फ और सिर्फ जब बनाना होता है जब आप y एक्सिस से रोटेट कर रहे हैं, ठीक है. और एरिया निकालने की ऐसी कोई कंडीशन नहीं है. डिपेंड्स वेयर द एरिया इज. इफ द एरिया इज बिटवीन द कर्व एंड द y एक्सिस, यू मेक x द सब्जेक्ट एंड you integrate with respect to y. Okay, we're doing the same thing here also, and there is no standard rule कि अगर area volume चाहिए तो हम हमेशा x को subject बनाएंगे. It depends what the area is in between. Okay, if it's in between the curve and the x-axis, we do it with respect to x. If it's in between the curve and the y-axis, we do it with respect to y. Now, I will strongly encourage you to download the notes and do your revision from there. Okay, so we have found out the volume that is generated by the line. Okay, so ये आ गई line की volume. ठीक है, इसको अभी रख देते हैं साइड पे. तसल्ली से करना है आपने, कोई जल्दी नहीं करनी. पेपर में टाइम वेस्ट नहीं करना आपने, ठीक है. तसल्ली से करने का मतलब ये नहीं है दैट यू टेक अ ब्रेक, यू लुक अराउंड एंड स्टफ लाइक दैट. जस्ट मेक श्योर दैट यू डोंट टेक मल्टीपल ब्रेक्स इन बिटवीन. सो स्लो एंड स्टेडी बेसिकली. नाउ कर्व हैज़ इक्वेशन x is equals to y square plus 1. अच्छा चलें, if you were asking about, if that's what you were asking, then I take my words back. And I hope I've answered your question. Anyway, so we're supposed to make x the subject, which we already have, and we're supposed to square it also. So that means now we're going to do y square plus 1, the whole thing squared within the same two limits, minus 1 and 2, and we're going to multiply it by pi. Okay. Now this I would strongly encourage कि आप इसको expand करना. Okay, I would encourage that you expand this. Why? Because it will make it easier for you. Okay, if you expand it and then do it, it will make it easier for you. Although if you don't, I don't see, let me think. अगर आप इसको expand ना करें, आप इसको बगैर expand किए कर लें, expand करके कर लेते हैं चलें. Because inside the bracket it's not a linear expression, so it's best that we expand it and then do it. So y power 4 plus 2y square plus 1. Okay, so why am I not integrating it directly? Because inside the bracket it's not a linear expression. That's why I'm not integrating it directly. Minus 1 times 2 multiplied by pi. So now let's begin the integration. Y power 5 upon 5 plus 2y cube, add 1 to the power, divide by 3 plus y. And देखो, you only do it directly if inside the bracket you have a linear expression. Okay, you only do it directly if inside the bracket you have a linear expression. Do we have a linear expression inside the bracket? No, we don't. So we're not going to do it directly. Simple as that. Okay, now what are the limits? 2 and minus 1. Okay, now let's begin plugging in the limits, and I'm going to do the limits plugging in part directly into the calculator. So we have pi. Now let's plug in the upper limit, which is 2. So I want you guys to see how I'm doing it, so you can also do it the same way. So open your calculator, make a fraction, make a bracket, write 2 raised to the power of 5. Whoops. 2. Thing I don't like about this on-screen calculator is that it's very slow. Plus, once again, make a fraction, write 2, make another bracket, write 2, close the bracket, raise it to the power of 3. Write it as it is so that when you have to plug in the lower limit, you don't have to make a lot of changes. You can just simply replace 2 with 1. Okay, so what do we get? We get 206 upon 15. 206 upon 15. Let's check as we go along whether we have done it correctly or not. Yeah. Okay, now let's plug in the lower limit. For the lower limit, remember you're just going to change 2 to minus 1. Okay, so wherever you've plugged in 2, just change it to minus 1. So you have 17 upon 15. Okay. Now 206 minus 17. Here we go. Let's divide by 15. So we're looking at 63 upon 5. So pi into 63 upon 5, which is equal to 63 upon 5 pi. Okay, so that's it. It's the home stretch. Now what we're going to do is we are just going to subtract the two. So we have 39 pi minus 63 upon 5 pi. Let's see what that gives us. So 39 minus 63 over 5. What are we looking at? We're looking at 132 upon 5, 26.4. It's up to you how you want to write it. I would just write it as 132 upon 5 pi. Can anyone check if that's the correct answer? 132 upon 5. Or maybe max, what I would recommend is to write it as an improper fraction. That's the max that I would recommend. So let's just double check and make sure we've done everything correctly. Sir, can you please share this solved document? Okay, I'll share the solved document also. So y power 4, y power 5 plus 2y cube upon 3. Achha, okay, I just realized कि मेरी जो lower limit है ना, that's actually wrong because I only changed 2 2's, not the final one. Okay, just a minute. I just realized. Can anyone check if this is the correct answer? I'm pretty sure it's not because मैंने -1 जहाँ डालना था 3 जगह के बजाय 2 जगह डाल दिया, 1 जगह नहीं डाल दा. So the value that I've gotten after plugging in the lower limit is probably wrong. So 2 upon 3 with 2, write -1. The whole thing cubed. I found the error. Plus -1. In the end also, we're supposed to do plus -1. So it's -28 upon 15. Yeah. So this is actually -28 upon 15. Okay. Now. So 206 plus 28, that's 234, divide by 15, that's 78 upon 5. So 78 upon 5 pi is actually the volume generated by the curve. Now let's do 39 minus the answer. So that's equal to 117 upon 5. Is that the correct answer? 39 pi minus 78 upon 5 pi. It's always a good idea to check your answer, okay, using your calculator. अभी क्योंकि टाइम थोड़ा शॉर्ट है इसलिए मैं चेक नहीं कर रहा एंड इस कैलकुलेटर में टाइप करने में बहुत टाइम लगता है. But in the exam, I want you guys to use your calculator to check your answer. Like for example, you can check the answer for this directly. Okay, in fact, let me show you. Let me just show you for this part. Okay, how to check the answer for this. And make sure that you use this in the exam to your advantage also. So x square plus 1, the whole thing squared within the limits, minus 1 and 2. So 78 upon 5. Yeah. So had I checked after doing it incorrectly, I would have realized that I've made an error and I would have probably fixed that error. Okay. So I would strongly encourage that you guys learn all the ways that your calculator can help you check your answer. You know, you can check simultaneous equations, you can check quadratic equations, you can check quadratic inequalities, you can find out area within the limits, you can find out, what else can you do? You can find out the gradient at a certain point. There's a lot you can do. Okay, there is quite a lot that you can do, and I would encourage you guys to learn all those features and use it to your advantage so that when you're solving a paper, you know that you're doing it 100% correct. Sir, when will you finish the marking of your mocks P1 for the past paper? हो गया बेटा, P1 के mocks check हो चुके हैं, इब्राहिम. आपका grade आ गया होगा. How do you learn all those features? Better YouTube. You'll find videos on my channel, you'll find videos on other channels also, but थोड़ी effort कर लो. If you don't find a video on my channel, it's no big deal. Learn it from some other channel. Simple as that. Okay, so this is a question that I really want to solve, especially because how we're supposed to give the answer. So I kind of like that about this question. So let's solve. However, I'm just going to go grab some water and I want you guys to do the first part. शहीद बेटा आप थोड़ा पीछे कर सकते हैं, ठीक है? मैं पूरी बाकी सबको वेट कर रहा हूँ आपके लिए, आप स्ट्रीम आगे पीछे कर सकते हैं, ठीक है? Which stream will you do tomorrow? Most likely equation of circles. Most likely. Maybe another part of this if needed after the end of today's stream. If not, then I will do equation of circles. Achha, you were talking about the mock we did yesterday. The mock you guys did yesterday, inshallah, will be checked most likely in 2 days. Okay, so I'm just going to go grab some water. I want you guys to solve this and give me the answer. Okay, sorry about that. Didn't realize I was on mute. Yeah, so basically when you solve them simultaneously, you will get the calculator doesn't know what you're trying to do, right? So when you solve them simultaneously, what will happen is, I hope you guys can hear me now. Yeah, so what will happen is that you will get two x values, okay? So one should be positive and the other should be negative. Okay, so you're going to take the positive value, which I believe is 1, and the y coordinate is, if x is 1, then definitely the y coordinate is also 1. ठीक हो गया? अच्छा, अब हमारे पास a के तो coordinates आ गए. Now let's have a look at the following part, and that is we're supposed to find out the volume. Okay, so let's do that. Let's copy this. Okay, here we go. So let's plan. Let's plan our answer. It's rotated about the x-axis. Okay, so if it's rotated about the x-axis, that means the area is actually just between this part of the circle. Okay, it's just this part of the circle. Can you solve part A? Beta, I'll do the, okay, I'll set it up. You can do it. You can do the rest. So it's basically x square plus 2x minus 1, the whole thing square is equals to 2. Okay, so x square plus 4x square minus 4x plus 1 minus 2 is equals to 0. So the quadratic equation you're looking at is 5x square minus 4x minus 1 equals to 0. कोई confirm कर सकता है ये quadratic equation आ रही है 5x square, I think ये आ रही है, and just solve this and you'll have the answer. Simple as that. ठीक है? I mean, this should not be a problem, okay? Questions like these should not be a problem. Otherwise, you're just throwing away 4 easy marks. Okay, so we are finding out the volume of revolution when the shaded region. What's the shaded region? Shaded region is basically under this part of the circle. And what are the limits? The question made you find out the x coordinates. The question made you find out the coordinates of A. And you found the x coordinate to be equal to 1. So that means 1. And what about this? How will I figure out this x coordinate? So for this x coordinate, simply plug in y as 0. Okay, simply plug in y as 0. So x square plus y square is equals to 2. So we're finding out the upper limit. We have the lower limit, but what about the upper limit? Radius? Oh yeah, that's a brilliant idea. Okay, don't plug in y as 0. That's a brilliant idea. I don't know why I didn't see that coming. So basically r square is equals to 2. So r is equals to under root 2 because the radius is because the center is 0, so that means whatever the radius is, that would be the same as this x coordinate. So root 2, that's correct. Okay, now you could plug in. So this is basically for the upper limit. You could plug in y as 0. That's also all right, but this is even better actually. So if you plug in y as 0, you'll get x squared to be equal to 2, which means x is equals to under root 2. Okay, so what we're supposed to do is, we're supposed to integrate y square within the limits 1 and under root 2 with respect to x, and then we're going to multiply it by pi. Achha, here's the good news. The good news is that you don't literally have to square y. It's already been squared because since it's the equation of the circle, that means it's already been squared. Okay, so aapko square karne ki zarurat nahi hai. So what are we integrating? We're integrating 2 minus x square within the limits under root 2 and 1, and we're going to multiply it by pi. So what happens when you integrate 2? You get 2x. What happens when you integrate x square? You get x cube upon 3 within the limits under root 2 and 1 multiplied by pi. Okay? Now, keep your eyes on the prize. By that, I mean the way that you're supposed to give the answer. Okay, so this is the way that you're supposed to give the answer. Now, let's start plugging in the limits. Okay? So, if you plug in the upper limit, you get something like this. 2 under root 2 minus under root 2 cubed upon 3. Okay, so this is with the upper limit plugged in. Why not square the circle equation? So y is already squared. Why would you square it again? Now let's plug in the upper limit. That's 1 minus 1 cubed upon 3. Okay, and let's close the bracket. I didn't get how you got under root 2. Okay, I'll explain. So x square plus y square is equals to 2. Okay, now whatever this point is, let's call it x. It will have a certain x coordinate, but the y coordinate will be equal to 0. Correct? Now simply plug in, sorry, it's not x squared plus y square equals to 0, it's equal to 2. So simply plug in y equals to 0. So x squared plus 0 is equals to 2. So that means what's the x-intercept? The x-intercept is under root 2. Now obviously it's going to be plus minus, but the one that we want is the positive one. Simple as that. Okay, now we've plugged in the limits. Now it's just a matter of simplifying. So 2 under root 2 remains as it is. There's nothing we can do about that. Okay, but let's see how we can simplify this. Let's use our calculator for that. So 2, मैं आप लोगों के सामने ही कर लेता हूँ in fact, so that you can see exactly what I'm doing. Although I hate using this calculator, but let's do it. 2 under root 2 minus, make a fraction, under root 2. Okay, let's cube it. There we go. That's divided by 3. Okay, so what do we get? We get 4 under root 2 upon 3. Okay, minus Then let's do 2 minus 1 cube upon 3. 2 minus 1 cube upon 3 is basically going to be, let's just do it. 2 minus 1 cube is 1, so that's 5 upon 3. Okay. So keep your eyes on the prize. Now we can take the 3 outside, and I think that's it. That's all we have to do. So if I take the 3 outside, so we have pi upon 3 multiplied by 4 under root 2 minus 5. That's it. Job done. Why can't we simply solve directly through calculator? बेटा आप पेपर करने खुद जाएंगे या कैलकुलेटर को भेजेंगे? हाँ, कैलकुलेटर करेगा आपके behalf पे पेपर नहीं ना? You have to show your working. We've gone over this multiple times that you have to show your working. Open up any examiner report. You will find out that the examiner knows that you can solve integration within limits, quadratic equations, stuff like that in your calculator, but you are supposed to show your working. Simple as that. Okay, you can put the whole thing in the calculator, but only to check your answer. And that's something I strongly encourage. What I don't encourage is you guys not showing your working. Okay, so please use this calculator to your advantage. Don't make it counterproductive. Use it to your advantage so that you can check your answer and see whether you're doing it correctly or not. Okay? Can you do infinity integrals? So no more of this. Let's do one of those infinity integrals also. We have time. तो infinity integral का एक question मैंने देखा था. I kind of liked it. Here, let's do this. So you can show again how to use calculator to find out area or volume. You can rewind the stream a little. Okay, you can go back a little and see how I've done. Otherwise, if I do another question, I'll show you. So, but when you input it in the calculator, I got it. No, you're probably doing something wrong. It's not possible that if you input it in your calculator, you get a different answer. Okay, find the exact value of integral of infinity upon 3, infinity and 3 as your limits, 2 upon x squared. Now, please don't freak out when you see infinity. Okay, if you see infinity, please do not freak out. Why? It's very easy. Probably the easiest 3 marks in this paper. I don't know where this is from. This is from February, March 2024, but probably the easiest mark in this paper. Easiest 3 marks in this paper. How? I'll show you. So first, forget about infinity. Okay, forget that there is such a thing. Just integrate it the normal way. We all can do that. It's going to be 2x raised to the power minus 2 plus 1 divided by the new power, which is minus 1. Okay, don't forget the limits happen to be infinity and 3. So what does this become? This becomes minus 2 upon x within the limits infinity and 3. Now my advice is that you take the minus 2 outside. So when you take the minus 2 outside, you have 1 upon x within the limits infinity and 3. Now you plug in the limits. Sir, question 3 part B. Okay, well, oh yeah, I think that's the area question. We'll do that next. So 1 upon infinity minus 1 upon 3. Okay, 1 upon infinity minus 1 upon 3. So what's 1 upon infinity? What is 1 upon infinity? What's anything divided by infinity? 0. Okay, it's as good as 0. Remember the example that I always give? One slice of pizza and the whole town eating it. So everybody gets what? They do get something, but it's as good as 0. Okay, you will end up with something, but it's as good as 0. So you have minus 2 into 0 minus 1 upon 3. Okay, so minus 2 into minus 1 upon 3, that's equal to 2 upon 3. That's it. You pick up any infinity related question, this is how it's supposed to be done. Okay, infinity will always be in the denominator. If it's in the numerator, you can't do it. Okay, so this is how questions like these are supposed to be done. Achha, somebody requested me to solve question 3 part B. So I'm going to do that now. I think it's a pretty cool question. I like to think of it as 1 over 0, thereby giving 0. That's not bad. 1 over 0, so that's 1 into 0 over 1. Therefore, it's 0. Yeah, I like it. Good job, Akmal. What happens if it's in the numerator? It won't be in the numerator. Okay, if it's in the numerator, you can't do it. It's not possible. Okay, the diagram shows part of the curve with equation y equals to x cubed minus 2b. It was February, March 2024. 2b x squared plus b squared x, and the line OA where A is the maximum point on the curve. Okay. The x coordinate of A is A, and the curve has a minimum point at b comma 0. Okay, so that b is equals to 3a. All right, so we're going to differentiate, set it equal to 0, plug in b, and then solve, and we should get b is equals to 3a. Okay. So we're going to set this equal to 0. Minus 4 upon 3, correct? I don't know which question you're talking about. So this is dy by dx at x equals to b, dy by dx equals to 0. Okay, so let's plug in b. So 3b square minus 4b into b plus 2b into b is equals to 0. Okay, let's see what happens. So 3b square. No, wait a minute. We're supposed to show that b is equals to 3a. Okay, no, sorry. We're going to plug in a because a is also a turning point, and then we're going to set it equal to 0. Sorry. So 3x square plus, wait a minute, it's going to be b square. Sorry. Just a minute. Let me just do it again. Sorry, my bad. So when you differentiate, you get 4bx plus b square. Okay. Yeah. Thank you. Achha. So at x equals to a, dy by dx is equals to 0. Okay. So at x equals to a means 3a square minus 4ab plus b square. This is equal to 0. Okay. Now what does this look like? This is basically a quadratic equation. Okay. This is basically a quadratic equation. So 3a square minus 3ab minus ab plus b square equals to 0. Okay, so we're doing middle term breaking. All right, we're looking for factors of 3 because if you multiply the coefficients, you get 3 that give us minus 4. So that's minus 3 and minus 1. Okay, ये part आपको खुद सोचना पड़ेगा. This is not something, there is no formula, no nothing for it. This is something that you have to think about yourself really. So 3a into a minus b, okay, and then you have to take minus b common. That will give you a minus b is equals to 0. So we have 3a minus b into a minus b is equals to 0, which means 3a is equals to b, or a is equals to b. Now a equals to b we're going to ignore. We're just going to focus on b is equals to 3a. There you go. Okay, so this is what we were supposed to do, and we were supposed to find out that b is equals to 3a. We've done that, so there you go. Okay, then the question says, show that the area of the shaded region between the line and the curve is k a power 4, where k is a fraction to be found. Okay, so show that the area of the shaded region between the line and the curve is k a power 4, where k is a fraction to be found. Okay, so this should be fun. Let's see. Area between the line and the curve. Sure, but why ignore it? Is it not a... It's not relevant. Okay, we're ignoring because it's not relevant. This is May, June 2020, paper 1, variant 3. Okay, now. Let's see. Show that the area of the shaded region between the line and the curve is so and so. Now, how will you find out the area of shaded region? You'll find out area under the curve minus area under the line. Okay, now when it comes to area under the line, what is this area actually equal to? This is actually equal to area of triangle. So you can do it like that also. Okay, you can find out the area of triangle as well. That's what I'm going to do, in fact, because we don't have the equation of the line, so I'm not going to waste my time finding out the equation. We're going to do area of triangle. Okay, now let's find out the area under the curve. What are the limits that we're going to use? We're going to use 0 and a. And since we're supposed to do it in terms of a, so we're going to replace b with 3a. Okay, so let's find out the area under the curve, for which we will integrate x cube minus 2bx square plus b square x within the limits 0 and a. Okay. Then what is a coordinate? A has coordinates a comma, and you can plug in the a coordinate into, you can plug in x equals to a into the equation of the curve to find out the corresponding y coordinate. We'll do that, okay? So be a little patient. Koi jaldi ki baat nahi hai. Let's do it step by step. Let's not rush into it. So first let's find out the area under the curve. X power 4 upon 4 minus 2b x cube upon 3 plus b square x square divided by 2. Okay, and in this, we're going to plug in the limits a and 0. Okay, in this, we're going to plug in the limits a and 0. So let's plug in a. That would be a power 4 upon 4 minus 2b. Let's plug in a again. A cube upon 3. Let's plug in a again. So b square as it is. A square upon 2. So this is with the upper limit plugged in. Now the good news is that when you plug in the lower limit, everything becomes 0. So no need to simplify. Just write it as 0. So what do we have? We have a power 4 upon 4 minus 2 upon 3 minus 2 upon 3 b a cube plus a square b square upon 2. Okay. अच्छा अब एक काम करते हैं. Remember we found b to be equal to 3a, so might as well start replacing with that. So I see you're not writing. You can write dx. It's understood that we are integrating with respect to x. A good habit would be to actually write it. Okay, so let's, since we're supposed to give an answer in terms of a, okay, so I'm going to replace b with 3a. So this remains as it is. A power 4 upon 4 minus 2 into 3a into a cube upon 3 plus a square into 3a. Don't forget to square it upon 2. So let's simplify. This cancels. So you have a power 4 upon 4. Let's keep that as it is. Minus 2a power 4 plus, so 3 square is 9. So 9a cube upon, or 9a power 4 upon 2. Okay, so let's work this out. See what do we get. So you have 1 upon 4 minus 2 plus 9 upon 2. And that's equal to 11 upon 4 a power 4. Okay, let's put this on the side. Let's keep our eyes on the prize where k is a fraction. Okay, so it's supposed to be a fraction. Now let's talk about the area of the triangle. Okay, let's talk about this area of the triangle. Now we know that the base is a, but what about the height? How do I find out the height of this triangle? The way that we're going to find out the height of this triangle is by plugging in a into the equation of the curve. Okay, so let's plug in a. Y is equals to a cube minus 2b a square plus b square a, and also don't forget that b is equals to 3a, so let's plug that in also. So y is equals to a cube minus 2 times 3a square plus 3a square times a. So y is equals to a cube minus 6a cube plus 9a cube. So 9a cube minus 6a cube, that's 3a cube plus a cube, that's equal to 4a cube. Let's double check. So 6, 3 squared is 9, minus 6 plus 9, that's equal to 3, 3 plus 1, that's equal to 4. So that means this, the corresponding y value is equal to 4a cube. Let's write that down. Okay, so now time to put it all together. Area of the triangle, the 90-degree triangle, is equal to half into base into height. So 4a cubed times a, that's 4a power 4 divided by 2, so that's 2a power 4. Now the moment of truth, the final home stretch. So 11 upon 4 a power 4 minus 2a power 4, what's that equal to? Let's use a calculator. 11 upon 4 minus 2, that's equal to 3 upon 4. Can anyone check and tell me if this is the correct answer? 3 upon 4, a power 4. This is question number 3. And in the meantime, tell me, Mazaya. So I know it's a wrong stream, but please tell, although I have attempted many tropicals, it's topicals, okay? Tropical to temperature को बोलते हैं. Okay. अच्छा आगे क्या बोल रहे हैं? I have attempted many tropicals for mensuration, but new question में difficulty आती है. अच्छा. बेटा देखो, for some topics, what I'm going to say is that it's kind of okay to struggle. Okay, I'm not saying that you accept your fate and say that there's nothing you can do about it, but mensuration is a challenging topic. What you need to see is whether you're able to not solve the entire question or whether you are unable to solve maybe a certain part or two. If it's one or two parts, which I hope is the case, then honestly, just learn every question that you're unable to solve, see the concept being tested, and that's it. Don't make a big deal out of it. Simple. Okay, I'll give you guys a summary of this question. So long story short, you want the area of the shaded region. If this was a regular question, what you do is you'd simply find out the area under the curve minus the area under the line, which basically means area of the triangle. Simple. Now, in order to find out the area under the curve, you will use the limits a and 0. Okay, but that's not it. Your final answer is supposed to be in terms of a. So we integrate the curve, we plug in the limits a and 0. This is what we get. But this answer is not just in terms of a, it's in terms of a and b. So what we do is, in the previous part, the question has made us find out b in terms of a. So we substitute b as 3a here, and we write the final answer in terms of a only. So this is basically area under the curve. Achha. Then after that, we find out the area of the triangle. How do we find out the area of the triangle? We can clearly see what the base is. We need to find out the height, for which we plug in the x coordinate of a, okay, into the equation of the curve. When you do that, once again, you run into a problem, and that is the answer is not in terms of a only. So you replace b with 3a, since that's what you found in the previous part. You plug it in, you simplify, you expand, you simplify, you have 4a cubed, which is basically now going to act as the height. So base is a, height is 4a cubed, you find out the area of the triangle, and you have the area under the curve, you have the area of the triangle, subtract the two, you get the answer. Simple. Sir, बहुत मज़ा आया. Sir, थोड़ा roast हो गए आज, लेकिन चलें, I did not understand your question correctly, which is why I said what I said. Okay, excuse me, sir, can you solve question 40 part B? I can't. Didn't I already solve question 40? I think I did. Question number 40. So I'm just going to solve one more question. 51. And I do encourage you guys to solve these questions. आप लोग सब बोल रहे हैं कि वो कर दें. अच्छा, okay, talking about 40 part B. Okay. I know you guys are saying कि I should upload the solved version. I don't have a problem uploading it, but I would encourage you guys to solve these questions yourself. A triangle is formed from tangent to the curve at B to the normal to the curve at B and x-axis. Find the area of this triangle. Okay. All right. So when would you solve? Good morning. So 40 part B here. Okay, wait a minute. Before I take a screenshot, let's clear this mess. Here we are. Let's take a screenshot now. Okay, so a good idea would be to visualize the situation. A triangle is formed from the tangent to the curve at B. So let's see what that looks like. And if you're doing this in the exam, remember to use a pencil. Okay, so here is the tangent to the curve at B. ठीक हो गया? Okay. Tangent to the curve, the normal to the curve at B and the x-axis. Okay, normal to the curve at B. Now, I don't know if the normal to the curve at B is going to cut the x-axis at the origin, or maybe it's going to cut it slightly above the origin. That's for us to find out. Okay, so I'm not going to draw it in a way that it cuts the origin, otherwise it's going to be misleading. But let's just draw it like this, and let's find out what is the deal. So basically, the triangle that is formed is this triangle right here. Okay? Now let's focus on, so this will be the last question. Let's focus on the tangent. ठीक है, अच्छा यहाँ पे मैं आपको दिखा देता हूँ कि how you can also use your calculator to find out the gradient. Okay? So we know very well that in order to find out the gradient of tangent, we will differentiate. Okay, so before you differentiate, you'll make y the subject, correct? So y is equals to 4 into 2x minus 1, the whole thing squared. I mean, y is already the subject, but you will write it nicely. Now dy by dx is equal to 4 times minus 2, that's minus 8. 2x raised to the power minus 1, minus 2 minus 1, that's minus 3, multiplied by the differential of the expression inside the bracket. So we have minus 16 over 2x minus 1, the whole thing cubed. ठीक है, अब इसमें आपने plug in करना है 3/2. And we will get the gradient of tangent. Okay, so you're going to plug in x equals to 3/2. Now here's what I'm going to do. I am going to use the calculator now. Okay, so shift, press this key, type the equation of the curve, 4 upon, open the bracket, 2x minus 1, close the bracket, square it, write down the equation of x, which is equal to what? Which is equal to 3/2. How to avoid silly mistakes? But I don't have a solution for it. Otherwise, I would be the first one to give it to you. Just check as you go along. Check as you go along. It says base is x-axis. It doesn't say that the base is x-axis. Okay. It doesn't say that. This is from May, June 2023, paper 11. Anyway, so we have the gradient of the tangent, and the point is 3/2, 1. So let's form the equation. Y minus 1 is equals to minus 2, x minus 3/2. Okay, it does say at the x-axis, but the thing is, we don't know for sure. वो तो ऐसे भी बन सकता है, ऐसे भी बन सकता है अगर हम x-axis को थोड़ा extend करें. There is nothing, it doesn't say that the base is the x-axis, so we don't know for sure. A triangle is formed from the tangent to the curve, and I know it does say on the x-axis, but ऐसे भी तो हो सकता है. It doesn't say for sure whether the y-intercept is going to be 0 or not. Okay? So minus 2, x minus 1. Sorry, x minus 3/2. Okay, let's write this nicely. Y minus 1 is equals to minus 2x plus 3 into 2 is 6, 6/2 is 3. So we have y is equals to minus 2x plus 4. Okay. Now what did we want? We wanted the y-intercept, which is equal to 4. Okay, so from this tangent, we wanted the y-intercept, which we now have, and that's equal to 4. Okay, now let's focus on the normal. Now we don't have to do a lot of working for normal because we already have the gradient, so we just need to take the negative reciprocal. So the gradient of the normal will be equal to 1/2. The point through which it's passing will be the same, 3/2 and 1. Now let's put this together. Y minus 1 is equals to 1/2 into x minus 3/2. So y minus 1 is equals to half x minus 3/2 into 1/2, that's 3/4. Okay, so y is equals to half x minus 3/4 plus 1, that's equal to 1/4. ठीक है, तो देखा वही बात जो मैं कह रहा था कि it's not for sure that it's going to cut the origin. Okay, it's cutting it at 1/4 because that's what the y-intercept is. Okay, so please don't, I mean, looks can be misleading. Okay, so I'm pretty sure you guys have experienced that also firsthand. So just because you're making a rough sketch doesn't mean that whatever your rough sketch tells you, you take things to be exactly like that. Okay? So this is the triangle of which we're supposed to find out the area. Okay? So how is it 1/4 then it isn't a triangle? But क्या हो गया? कैसे पहुँचे A levels में? ठीक है, I'm trying really hard not to roast you, okay? I can't tell you how hard I'm trying. So this is the normal cutting the x-axis. This is the tangent cutting the x-axis. If this is not a triangle, then what is this? Okay, so the question said that the triangle is formed by the tangent cutting the y-axis. Did it say y-axis? Achha, no, wait. It said tangent to the normal x-axis. ठीक है, okay. So if it's not the triangle, then tell me. Okay, ठीक है, I get what you guys are saying. So what we can do is, we can extend this a little. If I extend this, then if this is not a triangle, then what is it? Okay, if this is not a triangle, अच्छा ठीक है, मैं समझ गया आपकी बात. Okay, आप ये कह रहे हैं, तो देखो बेटा मेरी बात सुनो, ये इधर भी तो कट कर सकता है ना. अभी निकाल लेते हैं इसका x इंटरसेप्ट क्या है. ठीक है, let's find out what the x intercept is. Let's plug in y as 0 and then let's find out what the x intercept is. So if I plug in y is equals to 0, ठीक है, so that would be 0 is equals to half x plus 1/4. It's still not 0. So minus half x is equals to 1/4. So x is equals to minus 1/2. It's still not 0. Okay, so yes, I agree. I thought that we wanted the y-intercept, but we actually want the x-intercept, so no problem. But it's still not 0. Okay? And it's still a triangle. That doesn't mean it's not a triangle. अच्छा, इसको delete कर देते हैं. ये मुझसे गलती हो गई. I was under the impression that we want the triangle formed between the y-axis. But point is, it's still not 0. It's still minus 1/4. Okay, and we want the x-intercept of the tangent, so let's find that out. Let's plug in y as 0, minus 2x plus 4. So 2x is equals to 4, x is equals to 2. So once again, it's not cutting at the origin, but it's still a triangle. Now the question is, what's the base and what's the height? Okay, what's the base and what's the height? So point B 90 degrees since it's tangent. Okay, but you're right, but it's not going to help us. You're right, but it's not going to help us. Okay, we can still find out the area. How? By taking this as the base. Okay. And by taking this as the height. Now let's take the base. The base would be equal to 2 minus 1/4. So let's see what that is equal to. 2 minus 1/4, 2 plus 1/4, 2 plus 1/4, that's equal to 9/4. And the height will be the y coordinate, which is equal to 1. Okay? The height will be the y coordinate, which is equal to 1. Okay, now let's put this all together. Half into the base, which is 9/4, into the height. Let's see what do we get. So we get 9/8. 9/8 or 1.125. Can anyone check and tell me if this is the correct answer? It's 1/2? No, the height is not 1/2. The height is 1. Okay. So anyway, check kar lete hain. What's the answer to question number 40? It's okay. Yeah, I got 5/4. No, 5/4 is the correct answer. Wait a minute. So the x-intercept that we got is 2. Let me see if that's correct. The x-intercept is correct. And then the x-intercept over here is minus 1/2. Oh yeah, sorry, the base is 2.5. Yeah. Where did I get minus 1/4? Sorry. It's minus 1/2. Sorry. This is not minus 1/4. It's minus 1/2. It's actually minus 1/2. Okay. Now, So the height would be the base would be 5 upon 2, and the height remains the same. So that's how we get 5 upon 4. There you go. 5 upon 4 square units. There you go. Okay, so what's the lesson from this question? Make a rough sketch, read the question carefully, and remember the sketch that you've made is a rough sketch at the end of the day. So whatever your rough sketch tells you doesn't have to be exactly accurate. So if your rough sketch tells you that it's an upward sloping line, it's going to be an upward sloping line. If your rough sketch tells you it's a downward sloping line, it's going to be a downward sloping line. Okay? So I'll give you guys a quick recap of this. So there was a tangent at B and there's a normal at B. Both these lines are cutting the x-axis. Correct? So both these lines are cutting the x-axis. That's actually a note for myself also, because I thought that it's cutting the y-axis. Okay? Now, but if I were doing the paper, here's my excuse. If I were doing the paper, I'd be 10 times more careful. Here, I'm a little bit relaxed because I know if I make an error, you guys will point it out. Okay? But if I were doing the exam, I would be 10 times more careful. So this is the triangle that's formed. So that means we need to find out the x-intercept of the tangent. We need to find out the x-intercept of the normal. We already have the point of intersection, and its y-coordinate is going to serve as the height. So the two x-intercepts, the difference between the x-intercepts become the base. The y-coordinate becomes the height. Put it all together, you have the answer. So I'm going to stop here. I'll see you guys, inshallah, in the next stream, which is going to be tomorrow. I'll announce on my Instagram what I'm streaming next. So yeah, stay tuned. I hope you guys enjoyed. See you jate jate. If you haven't liked the stream, please do that, and also subscribe to the channel if you haven't done that yet. So take care, fellas. See you tomorrow, inshallah. Allah Hafiz. M1, inshallah, at 7 p.m. Okay, I'm streaming pulley, inclined plane at 7 p.m.